Hey, hi friends, everyone. Good evening. Hope you're doing great. Welcome back to the session. We are here joined today to learn about geospatial data analytics. As part of the first session, that is yesterday, we were discussing about the applications of the geospatial analytics in real world, or you can say analytics in the space of GIS data. And we did discuss the applications in the real world. It all started with identifying the outbreak, right? You can talk about the epidemiologists heavily using the GIS data to track and identify the pandemics like the disease outbreaks. Then it is also used in politics. It is used in what I mean, everywhere. Ultimately, it is used everywhere. GIS data. It all needs to be done is that we need to add the locations of the Earth, I mean, geographical locations into the data, and we will be able to do a lot of analysis on top of the GIS data. It's used in military, army, right, in defense systems. It is used in agriculture. It is used in real estate. It is used in healthcare, as we have seen, right? So there are many such areas where GIS data is used, right? In fact, if you talk about GIS data in today's world, without Google Maps, without maps, I would say, we'll not be able to navigate anywhere, isn't it? And we have also talked about remote sensing. The concept of remote sensing actually helped GIS data, GIS or geospatial analysis to revolutionize itself. It drastically changed the way the geospatial analysis is done. And remote sensing basically is getting the data without making a physical contact, right? So that reduces a lot of cost with respect to getting the geospatial data. And we've also talked about looking at the elevation cases as well. When we talk about geospatial data, elevations have to be also captured. And the problem with this imagery data, the remote sensing image data, is that it is a two-dimensional, right? It is only a two-dimensional object or image. So if you add the third dimension, then you'll be able to get the elevation as well. That is done by DEM. And these are different areas where we discuss that the geospatial analytics can be implemented. Some of them, I'm not talking about all the domains, this is partial, some of those areas where geospatial analysis is implemented. Now, today's session, right, as part of today's session, we will try and understand the biggest area that geospatial data has. I mean, the entire implementation requires data, right? And this is the most challenging area for geospatial analysis. If you talk about the data types, the formats, right? How do you store it? Where do you store it? What databases you use? What libraries we will be using to process the data? These are the gray areas. I mean, I should not say gray areas, but these are the areas that we'll have to focus primarily to start with. And if I talk about the formats, right, there are many different formats with respect to the GIS data, right? It talks about the file formats, the data structures, and the area is, I mean, the geospatial area is still growing, it's evolving. So new standards are coming up, improving from the older standards. And if you see, as I already mentioned, all we need to add is a location point, geographical location. So technically, any data that we have can be transformed into geospatial information data. All we have to do is add the location. So it gives you that very, very wide spectrum where you can see geospatial data. But all this geospatial data that we talk about are broadly categorized into only two forms of data. Right? They are broadly categorized into these two forms: raster data and vector data. Now we need to understand what is raster data and what is vector data. I mean, whatever the data sets that we talk about, right? It all converts into these two forms. A raster data basically contains a tabular form representation of your data. It is, as an example, you can see it is nothing but image or satellite data. If I talk about an image, then image is made out of pixels. So a raster data is nothing but collection of pixels in an organized fashion, rows and columns. Right? That's how we need to look at the raster data. And each of this pixel will have some value. Right? Each cell will represent a value. Each of this value that we are talking about is corresponding to a shape or shade or color. Right? And it's not mandatory that it has to be a cell, but it is the simplest form of looking at the raster data, raster type of data. So it's like a table representation. So we are calling it as a matrix. So it is nothing but matrix of cells. Each cell is containing a pixel value. And a pixel can store values from 0 to 255. That's from a computer vision perspective, from a machine level. Pixel can store value from 0 to 255. So a matrix of cells is organized into rows and columns. Or you can say a grid of cells that is representing your data is nothing but your raster data. The advantage is that each cell will be of the same size and same shape. There is one advantage that it will have. And it is generally used for continuous data. So from an analytics perspective, when we talk about data, right, preliminary analysis perspective, data is broadly categorized into continuous data and discrete data. Okay, these are the two broad segmentations. So your raster can be continuous data, and the other form, which is called as vector data, can be looked at as discrete data. So when you have large continuous areas that you want to show, then you can use this image data, which can probably categorized as raster data. Using this, we will be able to talk about the variations in the temperatures, the area pressures, the soil conditions, right? Different things. So all these are some of the examples that you can talk. Ecotones, elevations, flow, distance. Then you talk about precipitation, right, with respect to rainfalls and all that. So this is an example of raster data. Now, raster data sets, when we talk about, is explained as an image, right? I basically am explaining that by default raster data is an image, but it is not necessarily only an image, right? Raster data can also be in text format or in something called as blob storage. There's something called as text blob library, in fact. This basically is nothing but binary large objects. The full form is binary large objects. If you are familiar with textual analytics concept, then you'll probably have heard about text blob. Right? So we are basically saying that raster data is not only image, but can also be in textual format. right? The primary difference, right, when we talk about image, I mean, you may say that, hey, I'm taking regular images, probably I'm doing a selfie, right? So you need to understand that the raster data image, which basically talks about view of a location, geographical location, will be very different from your regular image. The resolutions will be very, very high, right? And these digital images always talk about resolution with respect to dots in the space, right? More number of dots means more resolution. It's ultimately the number of pixels in an image. That's nothing but your resolution, right? So the resolution with respect to geospatial raster data will change. It's not the same way as your regular data resolutions are actually looked at. So if you talk about resolution of a regular image, we speak about the total number of pixels in that particular image, and we generally have megapixels. Okay? Mega is 1000. When we talk about raster data, the resolutions can be basically mapped through the distance, right? Each cell that we talk about is representing a location. So the distance between these two is something that we basically look at. That's the resolution mapping that we do. Okay. Next, coming to your vector data. The vector data is a little different from what we basically know here with respect to raster data. If you compare, raster data is like your images, whereas vector data is actually represented as points, right? Data points, not on a image perspective, but it is from an X and Y coordinates perspective. We are talking about sequential data. Each data point is nothing but a vertex, or basically you can talk about data point in an X and Y coordinate. Okay. So these basically contain latitude, longitude, these kind of things. Positive values, negative values with respect to the dimensions of Earth are basically given. Okay. And these are basically used for representing the data points on the screen, computer screen. All right. So if I have to talk about an example here, the borders, the linear features, roads, rivers, right? These are the examples of vector data. I mean, coordinates with respect to the borders, for example, right? The length of the roads, the dimension of the roads, distance perspective, the X and Y coordinates that we capture, right? So that is your vector data. So you can also talk about timestamp. Right? We are recording timestamp in respect to the GPS data, right? That is an example of your vector data. Timestamp becomes an vector data, right? So these are broadly right, explained or categorized forms of geospatial data. We'll discuss this probably using more examples as and how we proceed further. But whatever the data that we get is ultimately categorized into raster data, which is image data, and vector data, which is like sequential data points here, numeric data points, which talk about the X and Y coordinates of the fields. All right, so that's basically your data types. The vectors will have same sharpness even if you zoom in or zoom out. right? The sharpness will not change. That is one advantage that we have with the vector data. Whereas here in raster data, the cells will have same shape and size. Then when we talk about the different types of data formats, I mean, physically the data that we are storing, right? The formats can be explained as raster data and vector data, but physically the data file formats can be explained like this. It could be any of the generic data types or data formats that we have. And each of this format will come up with its own challenges. Right? How do you process the data? How do you access the data? So all those are the challenges that your regular spreadsheets or CSV files or TSV files will come up with. As I said, each file format has its own challenges, because to access the data and to process the data, there will be certain ground rules that we have to follow with respect to these file formats. Right? And before we deal with anything, we first kind of do pre-processing, right? So each of the file format has its own standards. So that is the challenge with respect to the file formats or data types that we're speaking about. Geotagged photos can be there, binary points, lines, polygons, elevation data, right? DEM, I talked about elevation data model, XML form files, JSON files, web services, the GeoSpatial databases. There are certain databases that you might be already familiar with, right? For example, Google Maps data. It's a geospatial data only, right? Google Maps. We also have Google Earth. In fact, from Google Maps, we have Google Earth. Then we have something called as what is this? WMS. This is Web Map Services. If you are a person coming from a business intelligence background, you'll probably be using these kind of right, open public databases. Open Geospatial Consortium. This is the version that generally softwares like Tableau or Power BI use. OGC. Right? It's one of the versions of Web Map Services. Then we also talk about ArcGIS system, Silly Maps. Then we also have Open Layers, OpenStreetMap. In fact, OpenStreetMap is OSM. That is another popular public database. This is nothing but OpenStreetMap. These are options that you can use with respect to your business intelligence tools. All these databases that we are speaking about right now, right, the examples that I'm giving, OpenStreetMap, Open Layers. Then we also talk about the TerraServer. All these examples, the WMS examples, right? These are all geospatial data which allow us to do navigation. I mean, the whole and primary purpose of using these databases, open databases, are to help people navigate. So we are using geographic coordinates to do that. Right? So that's about your geospatial data databases. Next, we will also talk about the libraries that can be used with respect to processing this data. Right? In Python, we have so many different libraries that we can use. So we will try and look at hands-on with respect to some of these libraries, or maybe one or two libraries, depending on the time and right feasibility that we can. These are all the major libraries. Of course, there are many other libraries that we can also see. And there are upgrades happening to these libraries also. We'll look at the latest versions of these libraries with respect to the Python 3 version. Yeah. So if I talk about GDL, right? GDAL, in fact, GDAL stands for GeoSpatial Data Abstraction Library. This is called as, let me write it, GeoSpatial Data Abstraction Library. Right? So that's the GDAL library. This was basically simple feature library. OGR is also something that we call it. This is public library. It has two different libraries that we can get, and we need to install the GDAL package, and also OGR functionalities can be given. And I think this is a pretty old library, 1990s itself, and it is first released in 2000. Okay, geospatial analytics itself is an area which has slowly evolved. So 2000 is kind of a decent time, right? And yeah, that's basic history. It uses C++ more rather than using the Python libraries and the hands-on, basic hands-on that we talk about, right? It is more oriented to C++. And it contains raster data. Okay, that's something that you need to also remember. So all the raster file formats that we have, your GDL can support the raster data file formats. There are more than 200 file formats that your GDAL can support, right? And GDAL enables remote sensing functionalities as well. And it is considered as the industrial standard. Okay, for open source, open source libraries, we have this GDAL considered as the standard. Okay. So that's about a brief intro about GDAL. Then we have a library called Shapley. Again, this is a Python package. Straight away, it's a Python package. Right. And it basically comes from PostGIS. PostGIS is a functionality, or you can say a library from your Postgres SQL database. Right. And it really does not have any file formats or coordinate systems that you need to be talking about integrating different things. Shapley only deals with dealing with geometrics or geometries of the or geometries, I should say, right? And it just does not talk about reading or writing any geospatial files, right? It only helps you to analyze. Okay. We will be probably looking at that at a later stage. Then we have something called as GEOS. This is an open source library. It's called as Geometry Engine. Open source. Geometry open source. It also again primarily deals with C and C++. Right? But these are some of the libraries that you probably can use. The Shapley library that we are speaking about here uses the functions from GEOS library itself. So rather, you can talk about GEOS first and then Shapley. All right. So these are some of the examples. We can also talk about PySheep. Again, it's a pure Python library. You can see the library name also. So there is no other language. It's only Python programming library. And it basically allows us to read and write the shape files. There's something called as shape files. Right? And this PySH library is basically used to work with shape files, that is, right, standards for Python. Okay. Then we have Rastero, Raster IO, in fact, you can say. So it's a NumPy based library, and it also uses these GDAL standards, right? And basically it supports the raster data, right? And it is basically developed in Python from core, right? Using Python languages, it has been developed, right? And Raster IO is again an open source project here. This is also an open source. And they are basically, it is developed by one of the satellite imagery satellite team. Raster IO. Okay. Next, we talk about Jio Pandas. This is probably one of the simplest library that you can talk about. And this one supports vector data. So Raster IO supports raster data. Jio Pandas supports vector data. Right? And it basically is working on top of the Python standard library, which is Pandas. Right? And Jio Pandas was basically created to work with spatial data and using Pandas capabilities. Right. So when we talk about SciPy library, it's a very scientific Python calibrations, right? But it does not support, or it does not read geospatial data, your SciPy. Okay. So it basically allows SciPy to now deal with geographical data. And like your Pandas, Pandas supports data frames and series, two different objects. Right? Pandas library in Python is a third-party library, and this is used to specifically understand the Python data structures. And Pandas will support data frames and series, right? Only these two. So we will be able to deal with geo data frame. This is Jio Pandas, right? So we'll say geo data frame, right? Like that. And then we say geo series. Okay, these are the two data objects that your Jio Pandas can support. Next, we have Fiona. And Fiona is also another library which can allow us to analyze the data. It will not allow us to read or write any data formats. So these are some of the libraries that we basically have. Now, if I have to talk about setting up, right? If you have to set up the environment. We will be doing this probably the hands-on tomorrow. We will first install and have Python, because we will be using Python, friends. So we will be having Anaconda distribution-based Python installation done, because it also gives us Jupyter notebooks or Spider environments, which are basically called as IDE. This is nothing but integrated development environment. So we will try and first install Anaconda distribution. This would give us Python also as a package. And once this is done, within this, we will have to create environment. Right? We can have virtual environment created. And post that, we will have certain libraries, mandatory libraries you can talk about, like NumPy, Matplotlib, right? Pandas, these things which we try to install. Okay. Next, once this is done, we will start. As I said, we will be using the readily available libraries. NumPy, one of the wrapper or one of the libraries that we use is PyProject. We will use that, right? Yeah, GeoSpatial abstraction library also something that we GDAL, right? That is also something that we will probably install to get the data. Okay, so this is basically how we try to install the libraries, and you know how to install the libraries. If you're not, then probably you might want to look at the Tame the Python program, which is being conducted. It is absolutely free Python training on 360DigiTMG YouTube channel. You might want to go through that so that you get an overview of what exactly is Python programming and how your Python programming can be learned easily to implement all these concepts. But for now, the scope of this particular session, we will assume that you have a fair bit of basic introductory knowledge on Python programming. So from that perspective, I'm talking about Python packages. And when we want to install any package, we will be using the tool called pip installer. And we say pip install the package name. Right, so this is the installation process. Okay, so we need to basically get all these things installed. And Shapely is something which we can also see that this kind of libraries are used in AutoCAD software as well. Right, so that's about your Shapely library or GDAL library. Then we also have PySHP, PyShape, and as we discussed, it's a pure Python library that is used to import and export the shape files. So it is specifically developed and it's specifically designed to work with shape files. Right, then we also have a bunch of other options like GeoJSON, Rastero, Jio Pandas, right? So all these are basic installations that we need to ensure that the environment is created with. And then you need to install all that, right? So once that installation is done, then we probably go into the GDAL instructions and GDAL instructions and OGR instructions. So this is basically about the libraries. right? That probably you will be installing. Now, once this libraries are installed, we need to start working with respect to the various projections that we have. Right now, we will be looking at some of these map WMS server, I should say. That's nothing but web mapping server, right? So we will be looking at that, and we'll try to define a solution for the problem that WMS is facing. Next, we do a lot of pre-processing and all that, and then we move on to talk about various other operations that we generally do. A shapefile can be stored into something called as PostGIS software. Right? We'll be looking at PostGIS. And we will try and do some operations with respect to how the data can be transformed from one form to another form. Then we will talk about, if I have to come back and talk about the certain aspects with respect to data. You need to understand data before you can do some kind of hands-on with respect to these libraries that we just spoke. So when we talk about the file formats, data structures, there are many data structures that we have spoken about. The data sets, though, are broadly categorized into two: raster and vector data. Right? So for geospatial data, there are certain common traits that we need to understand. Right? And when we talk about the geospatial data, we also need to see how the data can be optimized or how it can be stored. Right? So we can probably use compression techniques and all that. We will see that there are certain best practices. Some of the optimized, some techniques are optimized basically for achieving the, let's say, readability, or we want to make the data lightweight so that the processing can happen faster. Right? So these are some of the standards. I'm just giving you examples here. So based on the data that we basically work with, right, you will see that the latest of the libraries or latest of the structures, data formats that we are using are far very simpler, very simpler compared to the old formats. Right? Most of the formats, they're very simple. At the same time, when you say simple, the features also are not that capable, right? These libraries are not as capable as the previous ones that we have as the original, original format. Different standards are coming up as we discussed, right? And these latest features, latest standards do not include features as well. But what is important here is the data is very big. When we talk about geospatial data, data is going to be very large. Right? So if I have to use this data for geospatial analysis or analytics, we need data to be processed as quickly as possible, as quickly as possible, right? So when you're working with geospatial data, or analysis, we should not be worried about the data format, because majority of the time that we have to spend is to integrate the data into different systems. Right? And we are also doing the input-output of the data. So when you're dealing with these kind of data movements, then always remember simplest data formats are better. Right? So that is what the understanding with respect to data structures is. We need to have a simplest forms, basically. Next, as I said, these geospatial data points are very large. These are huge data files, right? And they can be megabytes or right gigabytes as well. So whatever the softwares that we are using, the libraries that we are using in analyzing the geospatial data will have one common challenge, that is they are slow. Right? They become slow. So to ensure that the performance does not come down drastically, we need to create the indexing. Right? Indexing is important. We'll have to have indexes. Right? And this index basically will allow, indexing is there in all the database softwares, including your SQL databases, right? That is the traditional softwares. So you can imagine that indexing is something which is mandatory. Right? This will basically allow the tool, whatever that we are talking about, right? It will allow us to help or allows us to eliminate possibilities, with respect to duplications, and also we will be able to do a proper search, right? Appropriate search, I would rather say. So this is with respect to indexing. We need to do the indexing. And when we talk about this indexing, tomorrow we will learn there are two types of indexing. Popular. There are many though, right? We have seen a lot of indexing techniques with respect to non-spatial data. But when we talk about geospatial data, there are two standards that you might want to learn. One is called as quad tree index. The other one is called as R3 index. Right? So quad tree and the other one is R3. Quad tree and R3 index. Each of these has its own capabilities. The quad tree basically uses a series of algorithms which are basically used for single kind of a task. Right? And we have nodes, and each node in quad tree index will have 4 branches. These branches are also called as child nodes. Okay. So if you imagine this as a raster data, image data, then the child nodes that we are speaking about are either in square or rectangle in shape when we try to represent the data in UI. Right. So that's a simple definition of quad tree. Then we also have R3. This is another form of representing the data. And when we talk about R3, these are more complex. These are very complex when compared to your quad trees. Now, R3s that we are speaking about, the format that we are speaking about here, right? The indexes that we speak about. These R3s basically are designed to work with multi-dimensional space, 3. Right? So if you have a 3D data, then how are we optimizing the data for storage is something that you will have to look at. That how you are managing the sequencing, the indexing, so that it is easy for your database as well as your Python as well as your application. So that's about your R tree index. Right, and we basically have boxes representation. So this is with respect to the indexing part. Next, when we talk about raster data, I've also spoke about that these are pixel data points, right? So you basically will have to look at each and every cell. By default, it is 256 by 256. These are simpler formats. We can also have the syntaxes and basically the cells, right, which are of 3 million to 3 million cells. Okay, so that's the point that we are speaking about with respect to grid. Because whatever the indexes that we are using, right, the spatial indexes, they try to have a grid of values, right? It basically calls us an integer grid. So it can be as simple as 256 by 256 right format, or it can also go into 3 million to 3 million or 4 million to 4 million transactions. Right. Next, we have something called as overview. This is one of the right file formats of raster. And yeah, these are again something that you might want to look at. Overviews basically are resampled, and then we will also reduce the resolution here for your raster data. You cannot right basically keep using a specific data type. Overviews is one of those data types which is right kind of mandatory. I mean, raster data, which is kind of popular. These are also called as, I mean, if I talk about overviews, these are also called as pyramids. Okay, these are called as pyramid. So we are trying to do pyramiding. We're trying to create a pyramid. So this is basically pyramiding. It's concept of subsample and interpolation, upsampling and interpolation. If you are familiar with again computer vision, you'll be able to learn all these concepts where image data can be further enhanced for our usage. Next, there's something that we call as metadata. What is this metadata? Especially for geospatial data, we need to look at the metadata. So what is this metadata? When you talk about geospatial data, right, majority of the data formats are basically containing the bounding box. As an identifier, we'll have to put a bounding box. Right. So when you talk about metadata, it is basically storing a standard, right? Different location altogether as a standard. And we are talking about the FGDC content controller, which is basically called as Federal Geographic Data Committee. This is right, very popular organization like Food and Development right Authority, FDA. Similarly, we have FGDC, Federal Geographic Data Committee. right? It also uses something like ISO standards or content standards for right digital digital position geospatial data. So metadata basically is nothing but information about information in short, if you ask me about that. So basic elements, right? When we talk about basic elements of the data earth, we're trying to look at all those basic information with respect to the examples that we just discussed. Any new initiative, right, we can probably use. And yeah, the latest of the European Union initiative is basically, I should say, stopping metadata requirements gathering because it's already there. The metadata that is already included will be Inspire library. It's called as Inspire, so that's important. Let me write it. So we're talking about Inspire, right? Infrastructure for spatial information in the European countries specifically. So these are standards that are being used, right? We basically call that as metadata. Next, each of the data set that we basically have, we will load the data and we'll try to understand what the data that we are dealing with. So we will also be doing some kind of a hands-on with respect to some of the library codes. We are basically using standard formats to execute the code, right? And it's always good to have interactive medium that will allow us to understand where, right, the issues arising, why the issues arising, and we will be able to address that. So that's about your file structures. All right, so tomorrow when we connect, I would show how we can create the GIS Postgres data, post-GIS data. Right? Using that, we will be able to start doing the hands-on as well. We will be using open source libraries only. We will not be downloading any special libraries. We will be using all open source libraries. And then we will try to deal with some of the data that we basically have, and we will try to do some kind of hands-on as well. Like how do I convert data from one format to another format? How do I add specific value? How do I delete some values, right? All these exercises are something that we are going to try and do in the next session. All right, for now, we talked about different data types, the pros and cons of having the data types. Then we also talked about the libraries. These are some of the examples of Python libraries. Then we also looked at file formats, not just data types, which is raster and vector, but we also are looking at the file structures like CSV, TSV, right? All those standard formats of GIS data. With that, I will try to stop here. We are trying to understand the overview of the entire program. So geospatial analytics, we try to understand the challenges with respect to data. So tomorrow we will try and do some more hands-on. Until then, please take care of yourself and stay safe, friends. Thank you so much and have a wonderful evening.